Welcome to our viewers, and thank you for joining us today for our first webinar in our MythBusters series. Are all object storage solutions the same, myth or fact? Presenting today is Sanjay Jagad, Senior Director of Product Management and Alliances at Cloudian. Welcome, Sanjay.
Thank you, Laura. Really appreciate it. And this is an exciting topic, right? I love the idea of a MythBusters series. In today's day and age, right, the goal for us is to figure out how do I dissect all the different information that is out there. Some of them are misnomers, some of them are FUDs, and get to the facts, right? What exactly is going on in the object storage landscape, and are all object storage the same? Is that a myth or a fact? So let's just jump right into it, right? As Laura introduced, my name is Sanjay. I'm the Senior Director for Product Management and Alliances. I've been in the storage industry for more than 20 plus years, and I've seen different trends going through this, right? The one thing that we know for sure is that the unstructured storage is growing like it's growing like at an enormous rate right now. There is the biggest challenge that people have is how do I manage this unstructured data growth, right? And we know that the traditional legacy storage systems are not capable of meeting that growth, and that's the reason why we are seeing so much traction in the object storage space. Right, object storage is a completely different storage system solution that allows you to scale and store a lot of this data in an unprecedented way, right? Whenever we try to think about a myth or a fact and trying to reverse this thing, one of the things that people should always do is let's just start with some very basic known facts. Right, so I want to start with the very basic concepts of what is object storage, what are some of the basic facts, so that we can have a ground level alignment on what exactly we are talking about, and then we start dissecting and saying whether all the object storage are the same, right? So let's start. Right, some of the things that you need to know, and I think I'll go into each of this topic is, like, object storage has been around there for more than 15 plus years, and I'll show you some history. Right, the other thing that is also very well known, and it's a fact that, object storage, unlike traditional NAS and SAN, uses a flat addressing format to store and access data. And what you mean by flat, we'll go into that. The other aspect is, unlike like your NAS and SAN protocols, object storage uses RESTful APIs for data and admin functionality. That means you use the REST APIs to access that data from anywhere you want. And the last fact is, in the last few years, I think there is no doubt amongst the industry, right, that the S3 APIs have become more of a de facto APIs when it comes to object storage. So let's go a little bit into details for all of these items, right? And when I say object storage has been around for 15 plus years, this graphic gives you a very nice pictorial view of where things are. And the reason why this is very, very important is I'll explain this in two different ways. One is, if you look at it, right, object storage has been there since, early 2000s or late 1990s. And you can see those things, right? There are technologies that were founded and companies that were founded and acquired by major vendors in the early 2000s. The reason why this is very, very important is, like I said, object storage has been around, right? People have talked about changing the way storage is built and developed and to manage the growth of unstructured data, right? There were standards that were come out, like SNIA had a standard, CDMI had a standard, and a lot of these early companies that you see, right, before the 2010, you'll see that a lot of these companies were built on those standards that were proposed. Now, why is that important? The reason why that is important is, as you come closer in the last 5 to 7 years, you see that, with the Amazon taking stronger control on how to shape the object storage space with their S3 offerings and the S3 APIs, the architectures have changed. S3, as I was talking about, has become de facto standards, And when you have old legacy architectures that need to now change and align with the new S3 APIs, there is something that is going to be dropped, and that's where the S3 functionalities come into the picture, right? So it's fact that they have been there. It's also fact that this old legacy storage systems were built on old standards, and that has influenced their design, and this is what is going to be a concern as we look at the modern object storage solutions and what are required. So that's one pictorial view that you need to keep in mind. Where is the architecture built on? What is the architecture built on? What are the fundamental capabilities? Because as you know, in any subsystems or any storage subsystems or any infrastructure subsystems, the underlying architecture has a big story and a big role to play. The second thing we talked about is when we talk about object storage, it's not like your traditional SAN and NAS, right? It's a flat system, flat addressable system, hierarchical systems. So why is that important? Because it is extremely scalable, right? There is no concept of a folder structure, but, the objects are arranged just by using key name prefixes on the object name, right? Every object has an HTTP reference, right? It's extremely open and flexible for data workflows and application integration, right? An object is nothing but a binary large object, like blob, right? Could be a file, could be email, could be an image, it could be anything, right? It doesn't have a definition. Think about this, if you go, there are multiple analogies that are available today, right? But the idea is you have one large container where you have all your data sets put in, and then there is a label on the top with this basically a metadata that tells you what all things are inside and how to access that, right? So basically, you have a bucket, which is basically a collection of objects, and you basically control the access through permission, right? The data is accessed using RESTful APIs. And when you talk about RESTful APIs, what the users see is you have an S3 API client, which is a RESTful API, and you access buckets, which are similar to, let's say, a LUN or a file system, right? Folders are an easy way to organize. Think about it as directories, right? And data objects is actually your data with metadata on it, right? And from an application perspective, what you see is you have an endpoint, right? Like you have a mount point in NFS or an IP address or a WWN in a SAN space, you have an access point, right? That is the endpoint, which is it could be a bucket.hyperstore.com, right? Or s3region.com. There is a region endpoint to it. And then you have your access key and secret key that allows you to authenticate to that particular bucket and access that data. Typically, you'll have your object names, which include the folder names. And remember, it's a flat addressable schema, right? So you have your object name / folder name / the actual bucket name / object name, and you basically go on and address all the different objects inside that bucket. So this is very simple. This is very different than your traditional storage systems, and this is where the APIs become a key factor. Right? Like I said, S3 is basically equivalent of a modern storage protocol. It's a RESTful API, so it has a way to give you connectivity, access control, data management, reporting. It can set some data management policies, whether it's WORM, it's tiering, encryption, billing. All those things are part of now a RESTful API set. Right? We today talk about S3 APIs because that's, as I said, right, is becoming a de facto standard. But, S3 APIs are evolving as the use cases are evolving, right? If you look at what Amazon is doing, they have introduced a lot more advanced functionalities, right? There is versioning, there is tiering capabilities, there is something called multi-part upload, which allows you to get more performance out of it by chunking those objects into smaller different chunks. There is a way to replicate this. There is a way to do IAM and role-based access controls. There is a way to do object locks for worm compatibilities, right? There's a way to do multiple batch operations. So these are all now, like think about this from a standard perspective, like, you would have your Ethernet standards. Now you have an S3 API, which is evolving day by day and growing day by day, and is becoming more of a default way of accessing data. This is not challenged, and this is completely understood, right? Amazon has continued to maintain that particular lead, and as I mentioned again and again, right, people have accepted, right? Even if you look at today, if you go to Google Cloud, you'll see Google supporting S3 APIs, right? So you'll see all major vendors and ecosystem providers and application vendors now say we support S3 APIs. So the industry has accepted that S3 APIs are now the de facto standard to address and access and store on an object storage system, right? So with that, right, we have established a few baselines for what is an object storage. It is a flat hierarchical system. It has S3 APIs, and it can scale. But when you start looking at what differentiates things, right, those are very common things that we all understand and agree. But so if you want to understand whether it's a myth or a fact, whether it's all object storage are same, you have to go to the next level of details and truth. Right, so the next level of details and truth mainly come from the fact that the S3 API compatibility is very, very important. Right, if you look at the poll question, right, many people have already said that S3 compatibility is a concern, and the reason for that will go into the details, but that is a crucial factor for differentiating different object storage solutions. S3 APIs are good. They are data access APIs. They give you a lot of functionalities. But with storage systems, when you're talking about enterprise, right, there's a lot that goes into the management of the storage. So it's not just the data path APIs like S3 APIs, but you have to talk about control plane APIs, the admin APIs, so that you can figure out how you integrate into your workflows, into your applications. How is the integration done? How is the user management done? All those things. How is the configuration done, installation done, scaling done? All those control APIs are also something that is vital when you are talking about deploying an S3-based object storage, right? And then you talk about the underlying architecture, right? One thing is easy to say, like, hey, we are an S3 storage, object storage. That means people assume that you're going to scale. Well, scale-out distributed storage systems are not easy. There is a reason why there are not many people out there doing that. This is a very difficult engineering challenge to solve. And that what is important is the underlying architecture. It dictates whether you can deliver on the performance, the data durability, and the scale. So looking underneath the architecture is also very, very, very important. And lastly, whenever you talk about enterprise-grade solutions, enterprises typically want robust feature sets, right? They require various different features that are aligned with the data management capabilities of their existing solutions, and they want that to fit into their existing workflows. That's what makes an enterprise storage system and a particular vendor or a particular solution an enterprise storage solution system. You have to have all those data management capabilities. So if you look at what more is needed when you start thinking about understanding how we differentiate different object storage systems, these are some of the key elements. Let's look into each one of them a little bit detail. When I say S3 API matters, it is very important to understand the word native S3 APIs. There's a lot of buzzword lingo that different vendors throw in, right? Let's just define what does native mean. Just because you run on the same box does not mean that it's native. When I say native means that, it has to be part of your architecture. That means that whenever an S3 API request comes in, you are basically directly translating that into the actual transaction in the bottleneck, right? You don't want to have a translator, right, where You are taking the S3 API request from the front end, but then you are translating that request in APIs into your underlying architecture API, because that's where the compatibility becomes a concern. Remember I showed you the slide of the object storage vendor landscape? That is why this is very crucial, right? A lot of these vendors who started much, much earlier before S3 APIs became the de facto standard have built their architectures on those legacy architectures. That means that, like say today, when Amazon or S3 APIs evolve with some new functionality, your underlying architecture does not have the ability to do the exact same thing what an S3 API does. You're going to have compatibility issue, right? Now, it should not be a gateway, right? So whenever someone tells you that, no, we also run S3 API natively, your question should be, is this API is getting translated internal to your systems, or is it native implementation where S3 APIs are directly communicating to the underlying file system and storage systems, right? This is a major differentiating factor. This is what defines the S3 compatibility. This is what defines the ability for that storage system to continue supporting new advanced S3 functionalities as we move forward. So this is one matter you should always consider and always bring up when you are evaluating an object storage solution. This will not only have issues with compatibility, but it will also have issues with performance and other factors. When you talk about compatibility, when you're building a storage system that relies on S3 APIs and the compatibility, the reason why that is very important is because if you are a storage system, you want to have a wide ecosystem of solutions that can use your storage system. Right? If your S3 APIs are not compatible, that means the application that rely on those APIs will not function ideally. Right? So it translates, compatibility standards translates into ecosystem of applications that support it. Ecosystems translate into where you can use those systems, object storage systems, and get more value from it. So it's a link that needs to be seen all the way through to your business outcomes. So access APIs and compatibility is very, very important. Now let's talk about the underlying architecture, right? When we talk about object storage, we talk about scale. And as I was saying, distributed scale-out systems are not easy, right? One of the things that people talk about is, we do distribution through namespace, global namespace. But that's one way of doing it. But the fundamental challenge is, in a distributed system, access comes from any node. And if you have to jump through multiple nodes or hops to get to the actual data on a different node, it defeats the fundamental argument of a scale-out system. So in a scale-out system, what you really want is a very distributed peer-to-peer network kind of architecture where data is never more than a hop away, right? And you are not tied to certain limitations of how many nodes you can have, what are the different capacities, what are the different kind of hardware you want. Those things should not be a criteria in terms of architecture, because those translate into limitations, those translate into performance issues, and those translate into your issues when it comes to maintenance of it. The other thing that you need to look at it is whether all of these nodes are running the same entire software stack. There should not be any translation of gateways or metadata. Right? We have seen solutions where they have few nodes who keep the metadata. What if I need to my access comes on another node, it doesn't have the metadata, now I have to go fetch it from somewhere else, I have to go update it. Those things don't translate in a distributed scale-out system. That is the reason why distributed scale-out systems are difficult. Right? So if you're looking for scale, you're looking for ease of management, you need to make sure that the underlying architecture is supportive of it. And now once you have the architecture, there has to be a way in terms of flexibility to see how you can deploy that scale-out system. Right? Your data that you are putting in an object storage at this vast amount of data, not all data carry the same sense of urgency of protection that you need, right? Your business SLAs might be different. Your business requirements might be different. You may want certain data to be protected in a single site with replicas, or you may want to get more efficiency and do erasure coding in a single site, or you may want to have multiple sites but still have redundancy and EC done at individual site, or you may have multiple data centers and you want to have a big distributed erasure coded stripe so that you get the maximum efficiency, maximum durability where you can sustain multiple data center going down. That's all flexibility of the architecture, right? Because you never know how your environment is going to grow, the amount of data you're going to grow in a distributed world, in a geo-distributed world. When you're building cloud applications on top of this object storage system, you need to have ultimate flexibility. So those topologies are very important. Lastly, when you do all those topologies, they should not be system-level things, right? A lot of times, yeah, we do all those things, but you can only have one system-level things, right? You can only do erasure coded that applies to everything. Or if you do encryption, it applies to everything underneath. If you do compression, it applies to everything underneath. If you do worm, it applies to every bucket underneath it. That's not acceptable, right? You need to have flexibility to say, hey, for this one bucket, I want to do RF. Or in this bucket, I want to do EC. I want to apply worm on this bucket because that's my compliance data. But I want to encrypt this particular bucket, or I want to compress this second bucket, right? All those different options at the granular bucket level are crucial when you are looking for value out of your object storage solution, right? It allows you to dictate what and who accesses this. It allows you to now create an environment that allows you to control flexibility-wise which data gets treated how and is protected how and is accessed how. And lastly, when you do scale out distributed storage system, you need to be able to do basic multi-tenancy and security, right? And when I say multi-tenancy, I mean it in both the ways, right? Multi-tenancy from a storage perspective, from a network perspective, and also from an administrative perspective, right? You need to be able to have basic way to separate out different tenants and groups so that they can be shared environment. Like, a lot of service providers are looking to build services on top of this. Or if you're an enterprise, you're looking to build S3 as a service for different groups, and you need to be treating each group separately. You need to have the access controls for each of this multi-tenant environment, for each of this tenant. You need to be able to control policies on each of this tenant. You need to control the authentication. You need to be able to have QoS monitoring ability so that you can control the workload so you don't have noisy neighbor issue. You need to be able to have, the ability to monitor traffic, right, and assign billing if you are a service provider, based on how many gates, ports, or whatever consumption matrix that you want to define. All those feature sets and data management capabilities are absolutely essential to make a true object storage in a multi-tenant scale-out environment, right? So these are all the things that really, really are needed to be considered when you are evaluating object storage solution. So we started this session and we talked about, are all this object storage same? And from my perspective, and at least from what we have seen from an industry, I think that's a myth, right? People assume certain things when they speak from a marketing language, right? Hey, we are an object storage, we speak S3 APIs. That does not define an object storage. As I said, right, object storage, there are some basic core functionalities that needs to be there, like there has to be a flat addressable system, it has to be there. But it is much more than that. The underlying architecture is important, S3 compatibility is important, advanced data management is important, control APIs are important. That is what differentiates object storage. So there's no way all object storage are the same, right? You will never see everybody the same. Then it defeats the purpose. And this, to me, is a myth. So let's now look at how do you evaluate object storage? And the best way to think about this is when you want to think about an enterprise class object storage, you basically need to have a checklist, right? We all know this. Whenever we go out evaluating certain things, we have a criteria, right? And we evaluate against those criteria. So let's establish what that checklist should be. The checklist could be as simple as 4 different categories. Whether the object storage solution has data and control APIs, right? Does it have native? And again, native does not mean that I'm running on the same box. Native is architecturally, does the S3 APIs are native so that I can get the S3 compatibility? Does it have the ability to support advanced S3 API calls and verbs, as we call it? Does it have control plane to manage, administer, report, monitor, right? Access controls? Those are all the things that you should evaluate an object storage on. The second thing is the underlying architecture. When we talk about underlying architecture, is it truly a scale-out architecture? And when I say scale-out, it has to be a peer-to-peer kind of an architecture where data is not 4 hops, 5 hops away. If you had 100 nodes, it cannot be at 20 nodes or hops away, because that is not how scale-out systems should be working. Right? It impacts performance. It has to be multi-tenant, multi-site. It has to be able to support smaller deployments and scale non-disruptively. It has to support different kind of nodes, right? Technology evolves at a very fast pace. You see drive technologies doubling it is increasing every year. You see newer Intel chips coming out every 2 or 3 years. And you want to bring in newer platform so that you get more value out of it, and you should be able to mix and match different densities. It cannot be so stringent in terms of how you can't go to Amazon and say, hey, I want object. They give you ultimate flexibility. Why should your on-prem storage be different? Data management is very important, right? Whenever you want an enterprise solution, like I said, right, you need to have data management, and that too at a granular level, where you can define different data retention policies, you can define data durability policies, RF, EC. You need to be able to align with your cloud natives, right? Hybrid or multi-cloud initiatives. If you are deploying this in a hybrid cloud environment, right? Are you making sure that you're not putting proprietary data sets, or at least giving them an ability to access that data in the cloud without being locked into accessing through your APIs? Can you deploy your entire cluster as a single stack inside the cloud? Those things are very, very important, right? It has to have proactive monitoring and reporting. And lastly, data protection, right? It has to be supportive of any number of nines, right? That comes from flexibility. You see a lot of times you will hear 11 nines, 12 nines, 14 nines. But that is a configurable on your deployment, right? You can deploy this in the most conservative way and get any number of nines, even 20 nines, right? It's as simple. Those are formulas. But your underlying architecture is what needs to be done. The metadata should be distributed. It cannot be on select few nodes, and now you are having to go to that nodes every time. It has to be on flash, because that's an operation that has to happen fast. It has to be scalable. It cannot be a fixed metadata that you have. It has to have an ability to put custom metadata on it so that you can now integrate with your reporting and Elastic Stack to search through your object. It has to have federal security regulations like FIPS, Common Criteria, SEC 17, all the things that are required for it to be a true enterprise solution. To me, that's what defines what an object storage is, what is an enterprise object storage. And to me, HyperStore right now checks all those boxes. It's an only enterprise-grade storage solution out there. And this is why reasons why enterprise choose object and Cloudian object storage solution. We don't have limits on scaling. We are 100% native. We support all the granular data management capabilities. We have all the essential features that are required when it comes to multi-tenancy, QoS, files, support, billing, security. The reason why Cloudian, again, goes back to our fundamental architecture, modular scalability, distributed global single namespace, and the hybrid cloud multi-cloud readiness. So if I go next level, peeling into why customers choose Cloudian, we have always stated, like, Cloudian has the highest S3 API compatibility, and we offer industries only guarantee saying that, if your applications use S3 APIs and they work with Amazon S3, you point them to Cloudian and it will work. We guarantee you that, right? Else we give you money back. We have the ability to support file, so that there are legacy applications that still rely on file access but still want to take advantage and the benefit of the object storage underneath. We have a file controller that sits on our object storage, which basically is more of gives you data portability. Like, file data can be converted into an object and can be accessed via object API, so you don't have to go through file. And vice versa, right? If you write data into your object storage, can be accessed via file. So that portability is very important. You need to be able to start small, like as small as 3 nodes and 100 or 150 terabytes, and grow up to hundreds of petabytes. You have granular data management. That's what our customers love about it. We have object lock, immutable storage, as well as other security things. And we are probably the only object storage solution that is a true hybrid cloud, multi-cloud ready. And what I mean by that is we are a software-defined object storage solution. So our entire software, every node runs the same software stack, right? So today, I can go into Google and deploy a 6-node Cloudian HyperStore cluster where I can combine, like I can run on 6 different VMs and create a big 6-node cluster to scale performance. And they have the full data management capabilities, full S3 functionalities, and I can have a cluster that spans on-prem and into the cloud or across the cloud. Data protection and replication is built in, and lastly, it delivers on the value of cost, right? We are literally less than a cent per gig per month when you look at what object storage brings to the value. This gives your customers the TCO. This gives them the ultimate benefit of having a distributed, true multi-site global namespace object storage solution, right? And lastly, the most important thing is it is proven, right? Today, Cloudian HyperStore is the highest rated object storage solution if you go to Gartner Peer Insights. It has received the highest rating. It has the most reviews. It has the highest recommendation. In fact, we won and recognized as the Customer Choice 2020 Object Storage Solution in Gartner's Peer Insights. To me, this is what is object storage, and this is what the session of today's is. So at the end of today's session, I hope you guys understand that no object storage solutions are same. That is a myth, and if you want to have a look at it, the true object storage solution or a true enterprise class object storage solution should meet with different checklist items as compared to APIs, data management, security, underlying architecture, and scale. That is what differentiates them. That is what makes object storage different. So with that, we will basically want to conclude on fact that with Cloudian, what we do is we allow you to we offer a scale-out distributed storage solution that infinitely scales and can deliver and allow you to meet infinite possibilities. Right? It's rich, easy to manage, easy to grow. It has the richest feature set, and it's proven in different worldwide deployments. So with that, we'll probably have a time for, I think, a poll question at the end, and probably a couple of questions from our customers.
Great. Well, thank you, Sanjay, for this great information and your time today, obviously, to present all of this. So I have a question here. What is Cloudian's solution to a distributed file system under a global namespace backed by Cloudian objects? Is it just an NFS CIF facade? Have you looked into Andrew file system family backed by Cloudian objects?
So this is a good question, right? So like I said, right, file system on top of an object storage solution is it can address different solutions, right? Cloudian with our S3 APIs compatibility, we have partnerships with many different file solution systems. I personally have not looked at Andrew file system, and I apologize for that. But we have partnerships with many different vendors, including Veka, Panzura, Nasuni, and many other different. We also have our own file controller, which basically is not a NAS box. Let me be very, very clear. It allows you to get your legacy applications to connect through an object storage, through a file interface like NFS or SMB, and be able to store data, file data into an object storage solution. Our current file controller is not a distributed scale out, and that's the reason why we have partnerships with different vendors to meet different customer use cases. I would be more than happy if you have any insights on the Andrew file system. But to me, those are a solution that delivers certain values both on object storage solution, right? And object storage gives you distributed scale out storage systems and the cost and the economics. So if your applications are not ready for S3 APIs or not ported to an S3 APIs, and you need to still have a file access, and you have certain performance SLAs, there are different file solutions on top of object storage solution that can be used. So hopefully that answers that.
Okay, great. And then why choose object storage over traditional hybrid flash arrays?
That's a typical industry debate, right? When you look at object storage, like I said, right, when you say traditional flash hybrid storage arrays, I'm hoping that you're referring to a traditional SAN on a NAS box. And it's very well understood the limitations of traditional SAN and the NAS boxes, right? They cannot scale over certain limits, right? You have distributed NAS solutions out there in the market, which are great. But what object storage brings is not only just the scale, but overcomes the limitations of file system. There is a way to now use the APIs, RESTful APIs, the metadata to do further advanced cloud app development that you cannot do on a traditional SAN on a NAS box, right? So we are talking about a completely different storage solution. But when it comes to price, right, like I said, right, object storage today goes as low as, at scale, you'll talk about less than 0.5 cents per gig. And I have not seen a single hybrid flash storage solution that can meet that kind of price points. And if you have that, I would love to see it.
Great. Well, so we'd also like to hear from you. What else would you like to hear about in our Cloudian MythBusters series? Please reach out to us and let us know. That's all we have. Thank you for joining us.